Bismillahirrahmanirrahim. Welcome to lecture number 11, Digital Signal Processing course, Spring 2021. And today we are going to start chapter number 3 of your course book, name Discrete Time Signal Processing by OpenAIM and Schaeffer. So, chapter number 3 is relevant to the Z transform. Let's talk a little bit about Z transform. Uh, we are computing Z transform with one objective in mind, that uh, we want stability analysis of only IIR system. So if somebody asks you why you studied Z transform with respect to the digital signal processing, so the best answer is that we want stability analysis of only IIR system. If you uh, search on your chapter number 3 and read the entire chapter, you might notice that OpenAIM talked a lot about IIR system, A of n, U of n, and minus A to raise for n, U of minus n minus 1. Anyway, both of these systems are IIR systems, right? And all of the rest of the system belongs to these two basic classes. But there is only one example, I think 3.8, that is relevant to FIR system. And he just said that for FIR system, your ROC will be entire Z plane. I'll discuss about ROC and Z plane today in detail. Anyway, so since I said earlier that FIR system are inherently stable systems, so we don't need Z transform analysis for finite impulse response system, FIR system. So this is only useful for the stability analysis of the IIR system. So let's start with the formula of Z transform. If you see the formula of Z transform, hopefully you have already knew about Z transform. So this is X of Z. ZT stand for Z transform. X of Z is equal to n goes from minus infinity to plus infinity. Let me write n here. So n goes from minus infinity to plus infinity. X of n, Z to raise from minus n. So this is the Z transform basic formula. N goes from minus infinity to infinity. X of n, Z to raise from minus n. So question arises here: is there any relationship between the earlier DTFT, discrete time Fourier transform, and Z transform? Because we want, if there is some relationship, we want to exploit that relationship. So your first topic of chapter number 3 is the relationship between Z transform and the discrete time Fourier transform. Um, Hopefully you have no issue with these formulas. You just replace e to raise for minus j omega n with z to raise for minus 1, right? So if we compare these two formulas, so n goes from minus infinity to infinity, n goes from minus infinity to infinity. So summation is same, x of n, x of n. So till here we have 100% similarity. However, if I see the last term, that is z to raise for minus n and e to raise for minus j omega, so from here we find that z is equal to e to raise पर j omega. अगर आप यहाँ से निकालें, माइनस कॉमन ले लें, so this would be j omega n, z to raise पर minus n, so it means that z is equal to e to raise पर j omega, right? So if I compare this with respect to the polar representation, if there is nothing written with E, it's mean that the amplitude is 1. So that's why R is equal to 1. Amplitude is 1. And if I see the angle, it is equal to the frequency axis, right? So it's mean that Z transform is equal to the discrete time Fourier transform, or Z transform equal to the Fourier transform at R is equal to 1, right? So if I explain it graphically, so I can say that Z transform is equal to Fourier transform at R is equal to 1. And for R is equal to 1, we use the term unit circle. I wonder whether you have studied about unit circle earlier in your classes or not. Are you familiar with the term unit circle? Let me zoom it. So this is r is equal to 1. Let me draw an arrow from here to here and make it red explicitly, and let me write with pen r is equal to 1. This is r equal to 1, right? So amplitude is 1. So this is your omega axis. Omega is equal to 0, and you can call it theta is equal to 0, right? So here omega is equal to pi by 2 and theta is equal to pi by 2. Why? Because theta is equal to omega. So whatever the value of that omega, it is equal to the value of theta. So here omega is equal to pi and theta is equal to pi, right? And here omega is equal to 3 pi by 2 and theta is equal to 3 pi. So this is value of r. So we can say that your Fourier transform is basically plotted on this black circle, and this black circle is known as unit circle. Unit circle has its significant with respect to the Z transform. Whenever you talk about Z transform, the term unit circle comes everywhere in your path, right? So we can say that Z transform is equal to Fourier transform at R is equal to 1, right? Any confusion?
No, sir.
So this shows that there is an interlink between Z transform and Fourier transform, and that interlink basically help us to find some interesting properties of a signal or a system by exploiting or handling both ZT and DTFT. Your chapter number 5, um, that will start after this chapter number 3, uh, is totally uh, relies on the interrelationship between Z transform and discrete time Fourier transform. So when we study chapter number 5, by staying at Z transform, we will get some interesting properties about the magnitude and the phase response of a system. And that's only possible because the relationship exists between Z transform and discrete time Fourier transform at R is equal to 1, right? So next topic is your right-handed sequences in your book. Right-handed sequences. Right-handed sequences. So right-handed sequences are those sequences that exist from 0 to infinity. Let me write first expression. Let me write the expression. Right-handed sequences. RHS. We use the term RHS for right-handed sequences. Right-handed sequences. And right-handed sequences are denoted by x of n, a to raise power n, u of n. Hopefully, so this is one class of system that belongs to a of n, u of n, and I don't need to explain more because we talked a lot about A of n, U of n during Fourier, the discrete time Fourier transform analysis as well. So let me graphically represent this expression. So we know that A of n, U of n would run from 0, 1, 2, 3 up till infinity. Right? So 1, 1, 1, 1. So this is basically the A of n, U of n. So since it is on the right side, if we have a plot from minus infinity to infinity, minus infinity to plus infinity, so right hand side will be here. This is your right handed sequence. It's from 0 to infinity. So you got the idea about right-handed sequences. Why it is called right-handed? Because it runs if we plot from minus infinity to infinity. So since they are from 0 to infinity, so it comes on the right side of 0 axis. So that's why they are known as right-handed sequence. Clear है बेटा?
Yes, sir.
Okay. So next, let's compute its Z transform. Let's compute its Z transform. Every now you're familiar with this term. So x of z, x of n, z to raise power n. And in right-handed sequences, our x of n is a to raise power n, u of n. So we can replace x of n uh, with a to raise power n, u of n. So I'm going to replace this by x of n, a to raise power n, u of n. So this is a to raise power n, u of n. Right? So what the effect of this u of n? What will be the effect of this u of n? It will change the limits from 0 to infinity, right? Because it is
Yes,
running
sir.
from it's running from 0 to infinity, so it will change this limit of summation from 0 to infinity. So that's the only difference. So let me do it in next step. So it will change from 0 to infinity, and from 0 to infinity. And we will delete u of n because it only controls the limit. Right? So a of n, z to raise for minus n. So let me combine this in same step. Okay, let me go to next step. I'm not confused now. Next step, what we are going to do, we are combining these terms. We can write this as a z inverse to raise for n. So this is a z inverse to raise power n, right? So n goes from 0 to infinity, a z inverse to raise power n. So now our life is little bit easy because we have formula that if beta, if we already know from convolution that if k goes from 0 to infinity, beta to raise for k, then this can be easily computed by 1 over 1 minus beta and beta mod less than 1. Agree, beta?
Yes, sir.
So now we are going to apply this condition on this summation. So so that we can simplify the expression. So beta mod should be less than, because condition is really important. So here beta is equal to a z inverse. So let me write here. So beta is equal to a z inverse in our case. So based on this, we can simplify this expression uh, like this, that this expression would be equal to, here, let me remove all this. So this will be equal to 1 over 1 over 1 minus is the inverse it's inverse, and let me put the condition. Here next I need to put the condition AZ mod AZ inverse R should be less than 1. एग्री करते हैं बेटा इस बात से?
Yes, sir.
So this is the Z transform expression for A of n U of n, and this is A Z inverse of less than 1. Let's do one more step. Expression will remain same. However, this would become A by Z equals C. A by Z, right? A Z inverse, so I can write this A by Z. I can delete this. This is A by Z. And this is perhaps equal to okay, let me do it next step. Expression is same. We can write this condition as Z mod greater than A. Can I write this as Z mod greater than A? There's some issue, wait please. Z mod greater than A. Agree करते हैं बेटा?
Yes, sir.
So this is the Z transform expression. Let me put some more spaces. So so this is known as Z transform expression. Z transform expression. And this condition is known as region of convergence. And in short, this is known as ROC, region of convergence. ठीक है बेटा? So now I can write this, what we found. Let me copy it again. Here, here. Then I plot this ROC next page. If you have A of n, U of n, and you want to compute its Z transform, so you will have 1 over 1 minus AZ inverse 1 1 over 1 minus AZ inverse, and you can copy this condition from here. Z mod greater than A. So this is let me write here This is your Z transform. So in your book, the formula is normally written like this: A of n U of n is equal to 1 over 1 minus A Z inverse Z mod greater than. So you know that the denominator will give you a zeros and numerator will give you a zeros and denominator will give you a pole. So 1 minus A Z inverse is equal to 0. So you can find the location of a pole from here. So now we are going to plot pole 0 plot, pole 0 plot and region of convergence, right? So pole, pole 0 plot. So we know that 1 minus A Z inverse is equal to 0. So since it is 1, so it has a 0 at Z is equal to 0, right? So there is no expression 1 minus. So it has only single 0 at Z is equal to 0. So 0 at Z is equal to 0 and pole 1 minus A Z inverse. Okay, so from here we can say that 1 minus it is like 1 minus equal to 0 equal to 0. So from here you can compute that 1 minus A by Z equal to 0, and from here you can compute that Z is equal to A. So we have a pole at Z is equal to A and we have a 0 at Z is equal to 0. So since we find pole and zeros, so now we can plot its pole 0 and we will talk about its ROC. So let me plot pole 0. So in Z transform, what you are doing first, you need to take this sphere or rectangle, then you need to draw anything inside this, like this. Let me draw this. This is unit circle, R is equal to 1, right? So this is probably the relationship with Fourier and Z transform. This is R is equal to 1. So since we have a location at, let me draw 0. This is your 0. And let's take A is equal to, assume, let's take A is equal to this one, pole at A. Right, so if you want to plot its ROC, you need to draw a circle at the location of a pole. So we have a pole at A, so our circle will look like this. So let me change its color by green, like this. Since we have a pole at, right, so we have a pole at A and we assume that A is less than 1. We assume A is less than 1, then that's why it is coming inside the unit circle. And Z mod is greater than A. So you know that your Z mod is greater than A. What does it mean? Your ROC will be like this. So that's how you plot ROC, right? Hope you got the idea that how to plot the ROC. So this is Z mod greater than A. It's mean that for right-handed sequence, ROC will be outward the location of it. So let me write this sentence explicitly because this is a key for right-handed sequences. ROC will be outward the location of the. Any confusion, beta?
No, sir.
So this is
No, sir.
all. Let me quickly revise what we have done so far. So far, we just exploited the relationship between Z transform and the discrete type Fourier transform, and we said that there is a relationship between Z transform and discrete time Fourier transform. By comparing this formula, we come to know that Z is equal to e to the raised power j omega. When we analyze, we come that R is equal to 1 because there is nothing written over here in polar representation, and theta is equal to omega. So when we plotted over here, so we said that your Z Fourier transform will be plotted on this unit circle. So you change frequency from omega is equal to 0, omega is equal to pi by 4, omega is equal to pi by 2, omega is equal to pi, 3 pi by 2, and again here omega is equal to 2 pi. So your Fourier transform is basically plotted on this unit circle. So next we started right-handed sequences, and we said that why it is called right-handed, because it is if we have axis from minus infinity to infinity, so it's coming on the right side of the zero. So these sequences are represented with standard form a of n u of n. So this u of n would run from 0 to infinity. So this is general expression. So when we open this expression a to raised power n u of n, this u of n will change the limit from 0 to infinity. We simplify and we come across this expression a z inverse to raised power n. And when we open it with this geometric sequences, we got 1 over 1 minus a z inverse mod less than mod. After simplification, we concluded that this is the Z transform expression 1 over 1 minus a z inverse, and this is ROC. So now we wrote up here. अगर आपके पास a of n u of n हो, so you can find 1 over 1 minus a z inverse and z mod greater than a. Then if we have a location, this expression right-handed sequence, we need to find out the 0 and poles. So 0, there is no expression on the numerator, so there is a 0 at z is equal to 0. So that is plotted by a red. This is 0 and this is pole. And pole exists at z is equal to a after simplification. So we plot this pole at a and 0 at z is equal to 0. And then since we have a z mod greater than a ROC, so we plot this z mod. अगर ROC के अंदर यूनिट सर्कल आ रहा हो, तो we call it system stable. अगर यूनिट सर्कल ROC के अंदर यूनिट सर्कल आ रहा हो, then we can say that the system is stable. तो हमारे इस पर्टिकुलर केस के अंदर भी आप देखें तो हमारे ROC सॉरी ये था, it's from green, it's not from black, right? So आप बताएं कि ROC के अंदर यूनिट सर्कल आ रहा है, because this is unit circle. तो ROC के अंदर यूनिट सर्कल आ रहा है, it's mean that system is stable. So we'll talk about stability and causality in a separate section as well. But this is just a hint that if you plot Z transform and ROC, and अगर ROC के अंदर unit circle आ रहा हो, so we say that the system is stable. Otherwise, it is unstable. ठीक है. अब let's solve a very simple example. अगर आपसे कहा जाए कि a of n example दो पोल्स हैं a of n b of n, the x of n आपको given हो 0.5 to raise for n, 0.5 to raise for n u of n, let me make it 0.3 plus 0.8 to raise for n u of n. So आप बता सकते हैं कि इसका Z ट्रांसफॉर्म एक्सप्रेशन क्या होगा और ROC क्या होगा? Can anyone help me to find the Z transform expression and ROC for this signal? Let me call it x of n for system. So अगर हमारे पास ये एक system है, IAR system, which is 0.3 to raise power n u of n and 0.8 to raise power n u of n, and you are asked to plot, compute Z transform and plot ROC. Can you compute?
Yes, sir.
So how? Let me quickly compute it. We have this one. So let me, we already know the pair A of n U of n is 1 over 1 minus a to raise power z inverse. So I can write that this would be 1 over 1 minus a z inverse. So in our case, first a1 is 0.3. So 0.3 z to raise power minus 1 plus what would be the answer of this second term, 0.8 to raise power n u of n? Same, but location
1
of
over
pole is
1
now
minus.
0.8 z inverse. Right, so this is Z transform expression. What about the ROC? So
Sir, now we have two poles.
yeah, so in case of a two pole, you need to take the common region. So let me write the Z mod, sorry, Z mod greater than 0.3 intersection Z mod Z greater than 0.8. तो एक 0.3 से ग्रेटर है और एक 0.8 से ग्रेटर है, तो आंसर क्या होगा?
0.8 से ग्रेटर हो जाएगा
0.8 से ग्रेटर हो जाएगा. Yes, excellent. So the answer is Z mod greater than 0.8. So अब यहाँ से हम एक रिजल्ट फाइंड आउट कर लेते हैं. Bring it up. So this is your final ROC Z mod greater than. Let me write it with pen as well. So this is your ROC. This is your Z transform expression. Right? So यहाँ से we can conclude one result that if there are more than one sequences, then ROC will be outward the outermost pole, because you have one pole at 0.3 and one pole at 0.8. So your ROC will be outward the outermost pole. जो बड़ा pole होगा उससे बाहर की तरफ आपका ROC होगा. Let me plot this. Let me plot it again. Let me take this. I am putting too much time on left right-handed sequence, so that when we'll jump to left-handed sequence, you can grab the concept very easily. So we plot this circle again. This is unit circle again. I'm stressing that this is really important. जब भी आप ROC plot करेंगे, unit circle आपने लाजमी plot करना. So black is basically a unit circle, right? So now we can plot pole zero location. So let me plot poles. We always have 0 at 0, and let me plot pole with this green. So we have one pole at 0, 0.3, and one pole at 0.8. So now what we will do, we will plot a circle at 0.8. And let me plot it. Green. Okay. And then ROC will be outward. So let me plot this now with same right color so that it is easy to do that. So now your ROC will be like this. ठीक है बेटा?
Yes, sir.
Yes, sir.
This is the brief concept of your chapter number 3. अगर आपको ये right handed sequence की समझ आ गई है, now you can build the your house on this foundation. बस आपको अगर एग्जाम में भी इस तरह के क्वेश्चन आते हैं तो you can plot ROC very easily by this. Right, so you can write this is Z plane. Right, so this is a Z plane and this is your Fourier transform DTFT on this unit. So since we set the foundation for left-handed sequences, now we are going to cover right-handed sequences in a very quick time. Let me move your topic. So your third topic is left-handed sequences. Left-handed sequences. We called it LHS. First, let me explain with why it is called left-handed. It is called left-handed because अगर आप माइनस इन्फिनिटी से -1 तक आए तो लेफ्ट हैंड सीक्वेंस यहाँ तक आएगा, माइनस इन्फिनिटी से -1, so from here to here. Since we are running from 0 to infinity on right-handed sequences, so from minus infinity to -1, this area is probably known as L left-handed sequence because it is on the left side of the zero axis, so that's why it is known as left-handed sequences. So it's running from minus infinity to -1. Since we included 0 in the right-handed sequences, so we are not going to include 0 here as done by OpenEye, right? So OpenEye counted 0 in the right-handed sequence, although it won't change any difference, but just for the sake of coherence with your writer. So your left-handed sequences, LHS, X of n, U of minus n minus 1. It is our left-handed sequence. A of n, U of minus n minus 1. Right? OpenEye intentionally add one more minus before this A, although it is not required for the representation of left-handed sequences, but OpenEye intentionally added this minus sign. I'll explain why he added this. Once we compute the Z transform expression, I'll press on this point again. But अगर हम ये point minus ना भी लगाएं, still it is on left-handed sequence. But OpenEye ने ये minus sign लगा के कुछ explain करने की कोशिश किया है. I'll explain this as well. So now let's compute its Z transform. So how we computed Z transform? We simply use this C formula, standard formula. X of Z is equal to n goes from minus infinity to infinity, x of n z to raise power minus n. But now our x of n is minus a to raise power n u of minus n minus n. So let me replace this x of n with minus a to raise power n u of minus n. Right, so let me put it in superscript. So now it is okay. Again, this u of minus n 1 will change the limits. So let me find out it again with this one, that this will u of minus n minus 1 will change the lower limit. So it's a lower and upper limit, because it is changing from lower and both upper limit now, because now we are running from minus infinity to minus 1. So now I need to copy this equation again, control C, control V, and let me change the limits. So I'm going to remove this u of minus and minus 1, and I am changing the limit from minus infinity to minus 1. Sorry. I think we are not going to change the lower limit, but this time we are going to change the upper limit. Right? In case of a right-handed sequence, we change the lower limit. In case of a left-handed sequences, our upper limit will change. So now this is same. Can I simplify this with equal sign like this? And I can bring the minus sign outside of this summation. Can I bring minus sign out of this summation?
Yes, sir.
Yes, sir.
Okay, so it's next step we are doing. We are further simplifying this expression by moving this a to raise power n, z to raise power minus n. So I can write this as minus a z inverse. Let me remove this n. Let me remove this n minus 1. ठीक है, हम ऐसे ही रखते हैं, ज़्यादा बेहतर हो जाएगा. Right. Now, now question from your side. When we change upper limit to lower limit and lower limit to upper limit, आपका जो अंदर के साइन है वो आपके नेगेटिव हो जाते हैं. मेरे ख्याल में आप एग्री करेंगे with these steps. What we are going to do now, we are going to change upper limit to lower limit and lower limit to upper limit. Can we do this? कि हम
Yes.
Yes, sir.
मैथ के रूप से अगर हम करना चाहें तो I think you are familiar, so let me do that in next step. So we can change the limit from 1 to infinity. We can change the limit 1 to infinity, but I need to change the signs of this one. So if a of n is positive, it would become a of minus n, and if z to raise power minus n, it would become z to raise power n. So that's how we change the expression. Agree करते हैं बेटा?
Yes, sir.
Yes, sir.
Let me write here reverse limit and change. तो याद रहेगा बात इसको. Right, great. What I'm going to do now, I'm copying it again. And what I'm going to do, change A Z inverse Z to raise power n. Now I can write this. Can I write this?
Yes, sir.
Now, in the next step, I am doing some sort of 7th standard thing. Let me +1 and -1. It will change anything? I just
No,
added one
sir.
x plus 7 minus 7. This is similar sort of thing. So let me bring this plus sign on the left side. So let me copy what I am trying to do. I'm trying to bring this plus sign here, 1 minus. So 1 plus minus 1, it is same. So I am trying to do next step, and I am removing this minus sign and changing the limits from 0 to infinity. I am removing this minus sign and changing its limit from 0 to infinity. So this is the ultimate simplification of this expression. Let me explain how. If you open this expression and try to find this value at 0, so A inverse 0 Z to raise power 0, anything raised to power 0 is 1. Agree करते हैं बेटा? Anything raised to power 0 is
Yes, sir.
1.
Yes, sir.
तो आप इस समीशन की 0 पे वैल्यू अगर निकालें तो A इनवर्स Z टू रेज पर 0 1 आ जाएगा, बट ये इसके बाहर क्या लगा हुआ है? माइनस साइन लगा हुआ है, तो इट विल मेक इट -1. तो हम क्या ट्राई करें, हम ये माइनस साइन को समीशन के अंदर लेके जा रहे हैं, बिकॉज हम इसकी लिमिट को 0 से स्टार्ट कर सकते हैं नाउ, बिकॉज ये जो माइनस साइन था ये हम इसके अंदर ले लें. एग्री करते हैं इस बात से? ठीक है बेटा?
Yes, sir. Yes, sir.
Now we are again confident to apply beta to raise पर k. हम इस सिचुएशन में आ गए हैं कि हम बड़ी आसानी के साथ ये अप्लाई कर सकते हैं सेम फार्मूला. k goes from 0 to infinity beta to raise पर k 1 over 1 minus beta mod less than 1. ठीक है बेटा? समीशन के ऊपर अब हम ये लगा सकते हैं. And now in our case, beta is not A Z inverse, but rather A inverse V. ठीक है बेटा?
Yes, sir.
ठीक है? Okay. Let's further simplify this expression. I know I can write this. I can remove this summation and replace with 1 over 1 minus A inverse Z and this A inverse Z is like this. Now I write its beta is A inverse Z to raise power A inverse Z mod less than 1. Less than 1. Okay, so can you simplify this expression? Can you simplify the expression further? चलिए ROC को simplify कर दें आप.
Sir, A should be greater than Z.
A should be greater than Z or Z should be less than A, because it would become because we are running short of time, so let me control C. Let me simplify this expression. ये आपने खुद ट्राई करना है. मैं फाइनल एक्सप्रेशन लिख रहा हूँ, इसका आंसर भी आपके पास आएगा 1/1 माइनस ए जी इनवर्स। जब हम इसको सिंप्लीफाई करेंगे तो इट वुड बिकम 1/1 माइनस ए जी इनवर्स, एंड इस जी ट्रांसफॉर्म एक्सप्रेशन वुड बिकम, उसके बाद दिस वुड बी जी मॉड लेस देन ए। Right, so this is your final expression. I'll explain from here, yes, tomorrow. The next class में जब भी होगी हमारी, so you will have a makeup class tomorrow at 2 p.m. after Jumma, right? So we'll take quiz after the class, inshallah. So this is your final expression. Now we can plot V transform here. So it has poles, zeros, 0 and B is equal to 0, and poles again at Z is equal to A. Let me plot.
Sir,
जी बेटा,
sir, क्विज का जो कह रहे हो it will be from chapter 2.
आपकी मेकअप क्लास आई थिंक सीआर ने आपको बता दिया होगा, लास्ट फ्राइडे को मैंने सेक्शन सी की ले ली थी, आप थोड़ा सा उनसे पीछे हैं, तो इट विल टेक वन मेकअप क्लास दिस वीकेंड, तो वी विल बी ऑन सेम पेज विद सेक्शन सी, बिकॉज आगे आपके मिड टर्म एग्जाम आ रहे हैं, तो वी शुड बी ऑन सेम पेज, ठीक है।
सर कल क्लास किस टाइम में होगी?
2 p.m.
ओके सर।
सर मिड्स
I
का तो
already
कह रहे हैं कि ईद के बाद होंगे।
ईद के बाद? I don't think so, because I did not have any information from the department yet. But anyway, this is your pole, and let me plot 0 is at 0, and let's take pole at A. Now we need to plot circle at A. Since we have a Z mod less than A, so our ROC will be look like this, right? So this is Z mod less than A. ठीक है बेटा, I'll talk more on this, and I'll find the expression with more than one poles as well. So, but for time being, you just need to connect that. In our case, the condition is from Z mod greater than A to Z mod less than A for left-handed sequence. ठीक है बेटा?
Yes, sir.
Okay, so with this, I'm concluding today's lecture. Let me stop recording.